They can't make me. I'm not going to gatekeep trigonometry anymore. So this is an SAT question that I actually really like. We have triangle JKL and we're told the sine of angle K. We're asked to find the cosine of angle L, and I think a pretty natural way to start this problem is to think, well, I guess let's go ahead and draw the figure and just kind of see what happens. We're told that angle J is the right angle and the other two angles don't really matter, so I'll just call it JK to the left and then L up top. And sine, you may have memorized this kind of mnemonic device, SOHCAHTOA, to help us remember that sine is related to the opposite side from a given angle, cosine is related to the adjacent side, and tangent is related to both the opposite and the adjacent side. And that's fine as far as it goes. What it tells you here is that if sine of K is 24 over 51, then opposite that angle K would be something proportional to 24, we'll just call it 24, and your hypotenuse would be 51. But if you think about what they're actually asking for here, we don't need any of that. They wanted the cosine of L. Well, the co in cosine has a particular meaning. It comes from complementary sine. The cosine is the same thing as the sine of the complementary angle. That is, if what we want is the cosine of L, this is going to be the same thing as the sine of the angle that is complementary to L. That is the angle that makes the other part of a right triangle. And so in fact, without doing any calculation whatsoever, and really without even having to draw this diagram, I should recognize that cosine of L is the same thing as the sine of K. I like this problem for the SAT because there are a couple of ways to get at it, but if you have a solid understanding of what trigonometry actually is, you can jump immediately to the correct answer here.